Welcome to the Fusion Note, a weekly dose of breakthroughs, curiosity, and connection, because the future is better when we build it together.
It's a pretty powerful way to start, isn't it? And looking at the stack we have today, I think we're actually going to live up to that promise.
I certainly hope so. But before we dive in, we probably need to clarify something for you listening. We aren't just reviewing standard news articles today. We are doing a deep dive into a Fusion Note.
Right, right. And for those who maybe haven't encountered this specific format, it's not just a newsletter. It's really this genre-bending experiment. It operates on the idea that you can't fully understand the future just by reading, say, dry science papers, or just philosophy, or just fiction. You kind of have to fuse them.
Exactly. So today, we're going to see some creative storytelling that actually acts as a metaphor for some really hard science. We've got some philosophical musings on what it means to, own intelligence. And then we have some very tangible, very cool tech updates.
Yeah, the overarching theme for this deep dive is, well, fusion, specifically the collision of biology, technology, and storytelling. We're going to cover literally everything from Microsoft writing data onto glass that lasts for 10,000 years to this very strange, microscopic journey inside the human body.
It is a wild mix. Our mission today is to really unpack what we're calling the new era of biology. We're going to try and understand a concept called levinating, which is basically learning to think like the biologist Michael Levin. And we're also going to explore how play might actually be the biological secret to high performance.
It's all about shifting your perspective. It's realizing that we are, as the source puts it, multi-scale beings.
Let's start with the spotlight section. And this is where that fusion concept really shines, I think, because this isn't a dry abstract. It's a story. It's a narrative set in the year 2026, and it features these two protagonists, Sophia and Kurt. So this is really a fusion note on writing.
Which I think is just brilliant. Instead of giving us a dense textbook definition of bioelectricity, the source uses fiction to map the territory.
So, the premise. Sophia and Kurt decide to go sailing within. They physically enter a human body, and they dock their boat behind the teeth along this curved wall of enamel.
Which is such a visceral image, right? It immediately reframes how you think of the body. It's not an object you look at in a mirror anymore. It's a landscape you can travel through.
Yeah, and they describe the air as warm and enclosed, but then they notice the light. And this is really the first major scientific hook masked as fiction. They wonder if the light is actually coming from their own bioelectrical field.
That's the big clue. If you're inside a mouth with the lips closed, it should obviously be pitch black. But the story is nudging us toward Michael Levin's core thesis here. We are electrical beings. We aren't just gears and fluids. We radiate fields.
Right. So as they travel deeper, they bypass the big 60%, well, which I'm assuming is the body's water content, and they take an elevator past the third eye up to the crown, which is the brain. But in the elevator shaft, they meet the neighbors, the Kims.
Oh, I love the Kims. The source describes them as this family of bacteria.
But they aren't just floating there like mindless dust. The story describes them as talking nonstop without talking. They use a 2D language and sound. What is that actually representing in the science?
That is a perfect representation of quorum sensing.
Okay, let's unpack that. What exactly is quorum sensing?
So for a really long time, we thought bacteria were just these lonely, mindless germs floating around doing their own thing. But we now know they communicate. They release these specific chemical signal molecules. And when the population grows, basically when the quorum is met, they change their behavior simultaneously. They coordinate.
Sort of like a microscopic flash mob.
Exactly like that. They can launch an attack, they can build a biofilm, or just go dormant. The story depicts this as a 2D language to show that they actually have intelligence. They function as a society. And Sophia can sense them, but she's tuned into that frequency. It's a reminder that we are sharing our body with trillions of other intelligent agents.
Wow, okay. So they leave the chatterbox bacteria and they reach the brain, and they have a very specific goal here. They want to turn off the light of cognition. They're looking for the off switch for consciousness.
Yeah, they are playing the role of the classic materialist in this moment.
Right. They've been raised to believe the brain is the absolute boss.
Yeah.
The CEO, if you flip the switch in the hardware, the software should just die. So they tried the left side of the brain, they flip the switch, nothing happens. They try the right side, still nothing.
This is the narrative directly challenging the whole idea that consciousness is localized to a single spot inside the skull. It's suggesting that if you simply turn off a neuron, or even an entire hemisphere, you don't necessarily kill the mind.
It's protected by these pyramid neurons, right?
Yes, And that leads to the part that really explains Levin's actual lab work. Kurt remembers some advice about goal setting. He suggests they stop trying to force switches and instead give the brain a new goal. So he literally asks the left brain to make a bridge.
Which is the ultimate takeaway from Michael Levin's research right here. Levin famously works with planarian worms and frogs.
Hmm.
And he showed that you don't have to micromanage every single cell to get them to build something. You don't have to be the foreman placing every individual brick.
You just showed them the blueprint.
You set the target state. You manipulate the bioelectrical field to say, hey, build an eye here or build a bridge here. And the cells, because they have their own local intelligence, they just figure out how to do it.
In the story, the neurons are a bit hesitant at first. They're like, I don't know if we can do that.
No.
But then they remember the frogs regrowing legs after being cut in half, and they just do it. A bridge appears.
It's called goal-directed regeneration. It means biology isn't hardwired like a silicon circuit board where if you cut a wire, the whole thing breaks. It's plastic. It's a collection of agents that can be persuaded to build totally new things if you just speak their language.
And that language is electricity, bioelectricity. Not the zapping kind, to be clear, but the subtle voltage gradients between the cells.
Right. So the story wraps up with them realizing the off switch for consciousness simply doesn't work because the cognitive glue river goes everywhere. They leave the brain and go visit Mrs. Hart, Mr. Gut, and the fascia tribe.
That's the real aha moment. Intelligence is distributed. When we talk about having a gut feeling or heartache, this suggests those aren't just poetic metaphors anymore. There is actual information processing happening in your fascia, your gut, your heart.
There's a line in the source that totally sums this up. Bioelectricity is the software that runs on the genetic hardware.
That is the one sentence you need to remember from this whole section. For 50 years, we've been completely obsessed with the hardware. The genes, the DNA. We thought if we could just tweak the hardware, we'd fix absolutely everything.
But Levin is basically saying the hardware is just the chassis.
Precisely. The genes build a protein, sure, but the shape, the complex structure, that's determined by the electrical software. And if we learn to code in that software, we could potentially fix birth defects, regrow limbs, or cure cancer without ever touching the DNA itself.
Which sounds incredibly like science fiction, but the Fusion Note transitions immediately to real-world news that proves we are already doing this.
We really are. The fiction is becoming fact a lot faster than we think.
Let's talk about the lab-grown spinal cords, because this is a massive breakthrough mentioned in the sources.
Huge. And notice the language they used to describe how they did it. They didn't just smash some cells together in a petri dish. They achieved this through fast-moving, dancing molecules.
Dancing molecules? I mean, that sounds a bit romantic for a lab report. What does it actually mean scientifically?
It refers to supramolecular chemistry. Usually when we build scaffolds for cells to grow on in a lab, they're static, they're rigid. But biological tissues inside you are dynamic. They're constantly moving and vibrating.
So they essentially created a scaffold that moves.
Yes. The molecules in this synthetic scaffold are dancing. They are in a state of constant motion. And this allows them to communicate much better with the receptors on the nerve cells. It mimics the natural environment of the body. Because the scaffold was dancing, the cells recognized it, latched on, and successfully differentiated into a spinal cord.
Which connects right back to Levin in the story. It's all about the state of the system. If it's static, it's dead. If it's dancing, it's alive.
Exactly. Life is fundamentally about flow and movement.
Speaking of things flowing and moving, there was a great article from Quanta magazine referenced in the note, The Biophysical World Inside a Jam-Packed Cell.
This completely changes the mental image most of us have. You know those textbook diagrams of a cell from high school, where everything is just floating peacefully in empty space?
Yeah, it always looks like a calm aquarium with one little nucleus just drifting by.
The reality is a rush-hour subway car in Tokyo. It is absolutely jam-packed. Proteins, organelles, RNA, they're completely shoulder to shoulder.
So how does anything actually get done in that kind of crush?
That's the breakthrough. The source suggests that maintaining the just right material state, meaning the viscosity, the phase separation, is absolutely crucial. If the crowd gets too tight, things freeze up. If it's too loose, they drift apart and reactions fail.
So a disease might not always be a broken gene. It might just be a cellular traffic jam.
Or a phase transition, like water turning to ice. If the cytoplasm gets too thick, the signals literally can't get through. Levin calls this state change. The big takeaway is that we might be able to cure diseases just by changing the physics of the cell environment, making it more fluid rather than trying to edit the genes themselves.
Okay, moving from the microscopic to the very practical. We
Yeah.
have dancing molecules, crowded cells, and a nasal spray.
Yeah, this is definitely the news you can use section.
The source mentions this new nasal spray that's showing incredible promise against a huge range of invaders, infections, allergens, viruses, bacteria.
It's a prophylactic approach. Instead of waiting to get sick and then treating the symptoms, you coat the nasal lining to just block the entry in the first place. But the real story here isn't even the spray itself, it's the regulatory environment,
Right. The note mentions the FDA is dropping the two-study requirement for this.
which is a very significant regulatory shift. Traditionally, to get a drug approved, you need 2 independent massive Phase 3 clinical trials. It takes years and costs billions of dollars.
And they are just waiving that.
For certain categories, yes. It seems to be a major lesson learned from the post-COVID landscape. We realize that speed really matters. If you have something that works and is demonstrably safe, waiting 5 years for a second study might cost a lot of lives.
Though it's worth noting, the source points out it was tested on mice, so we have to keep safety and ethical considerations in mind.
We always have to remember the animal models involved for sure. But the key takeaway for you listening is this shift in risk tolerance. We are actively moving from a zero-risk, slow-moving medical model to a managed-risk, fast-moving model.
Okay, let's pivot and unpack the tech side of the Fusion Note. We've talked about biological software, so let's talk about the digital kind, and it actually starts with a piece of glass.
Project Silica. This is Microsoft's research.
They claim they can store data on a slide of glass for 10,000 years.
A mini information seed vault, they call it. It's seriously impressive engineering. You use femtosecond lasers to etch data directly into quartz. It's waterproof, heat-proof, EMP-proof. You could drop it in the ocean, come back in a millennium, and still read it.
Finally, a hard drive I can't accidentally break. But you hesitated a bit when I brought this up in the pre-show.
Well, the source raises a very astute warning here. It calls it the noise bottleneck.
Explain that for us.
We are entirely obsessed with storage right now. We want to keep everything, every single tweet, every photo, every random sensor reading. But the source asks a critical question. Are we optimizing for meaning?
Just because we can keep it doesn't mean we actually should.
Exactly. If you have a library with infinite books, but no card catalog, and 90% of the books are just pure gibberish, are you smarter? No, you're just confused. The bottleneck isn't storage anymore, it's filtering. We are basically creating a digital landfill that lasts for 10,000 years.
That's a really sobering thought. We're digital hoarders building indestructible glass storage units.
And hoarding data naturally brings us to the next big point, AI. Because if you have all this data, who is actually analyzing it?
There was a really specific insight from the Cisco Summit about this from a speaker named Sam Peth. He used a real estate metaphor, rent versus buy.
I love this analogy because every business leader, and honestly every creative person, really needs to hear it. He asked, are you giving AI the front door key, or are you just renting the furniture?
He's talking about companies simply plugging into things like ChatGPT.
Correct. If your entire business strategy is, quote, we use ChatGPT, you are just renting. You are making a feature request to a brain owned by someone else. You don't own the weights. You don't own the underlying intelligence.
So what does buying actually look like in this context?
Buying means incubating your own model, taking a powerful open source model, keeping it strictly on your own servers, and feeding it your proprietary data. It's the difference between ordering takeout every night and actually learning to cook.
Right. If you order takeout every night, you eat, but you never learn the skill.
And you become totally dependent on the restaurant. If the restaurant closes or changes the menu, you starve. If you want AI to be a true competitive advantage, you have to nurture it internally. You have to raise the model yourself using your own enterprise data.
But that's scary for a lot of companies. The source mentions a real fear of marrying the AI.
Because once you bring it inside your firewall, the security risks absolutely skyrocket. And that brings us perfectly to Anthropic.
They released a cybersecurity version of their model specifically to help businesses defend themselves against hackers. But they drew a pretty hard line in the sand.
They did. They basically said, we will help you defend your servers, but we absolutely will not help you spy on your own employees.
Leave human surveillance to the Pentagon, essentially.
It's a fascinating ethical stance. We're seeing these AI companies defining their morality in real time. Anthropic is clearly trying to position itself as the responsible AI partner. deliberately distinguishing itself from the rest of the pack.
Before we move to the final segment, there were some rapid-fire energy quick hits. Australia launched a massive ship.
The world's biggest EV ship. It has a battery capacity equivalent to 487 Teslas.
That is an unbelievable amount of lithium floating on the ocean.
It really proves that electrification isn't just for compact commuter cars anymore. Heavy transport is actually happening.
And Fervo Energy set a new heating record in a geothermal project.
Geothermal is the sleeping giant of energy. Everyone always talks about solar and wind, but the Earth beneath us is basically a massive battery that never runs out. If we can drill deep enough and handle the extreme heat which Fervo seems to be figuring out, we unlock constant baseload clean energy.
It fits our fusion theme perfectly today, tapping into the hidden energy of the system. Okay, let's land this plane. We're going to Norway.
A very cold, dark place that somehow produces more gold medals than anyone else.
42 metals in the winter season. The source naturally asks, what is the secret sauce here? Is it the salmon? Is it the snow?
It connects us right back to the beginning of our deep dive. The secret seems to be work that feels like play, combined with cold surroundings, of course.
Play at the absolute elite Olympic level.
Especially at the Olympic level. The source links this back to the dancing molecules we talked about with the spinal cords earlier.
Connect those dots for me. How does an Olympic skier relate to a spinal cord molecule in a lab?
Think about the spinal cord cells. To form a complex, successful structure, they needed to be in a dynamic, fluid state. They needed to dance. If they were rigid, they failed. The Norwegian athletes seem to apply this exact principle to training. They don't grind themselves into dust with misery. They maintain a profound sense of play, of looseness.
So stress creates rigidity, and rigidity breaks under pressure.
Exactly. High performance, whether you are a microscopic cell or a downhill skier, requires a state of adaptability. If you are tense, you are slow. If you are playful, you are fluid. You can react to the environment.
And probably jumping in a sauna helps too. The source mentions the preventative sauna.
The Scandinavians absolutely swear by it, but scientifically it holds up. Heat shock proteins, improved circulation, it's all part of that continuous system of maintenance and repair. It keeps the biological state of the body optimized.
So what does this all mean for us? We've covered a lot of ground today. We've been inside the human body with Sophia and Kurt. We've looked at 10,000-year glass hard drives, and we've analyzed Norwegian training habits.
If we try to synthesize this entire fusion note, I think it really comes back to that phrase from Michael Levin. We are multi-scale beings.
Unpack that a bit more for the listener.
We aren't just one monolithic thing. You are a vast collection of cells, just like the Kim family in the story, and they have their own local intelligence. You are a biological machine that runs on electrical software. And externally, you are a user of digital tools that you can choose to merely rent or actively own and nurture.
It's all about recognizing the systems.
It's about recognizing that intelligence is everywhere. It's in the bacteria, it's in the fascia, it's in the dancing molecules.
And the whole concept of levinating.
To levinate is to see the body as a water machine running on light. It's to fundamentally understand that thinking isn't just something your brain does in isolation. Cognition floats and feels. It's in the space between things.
It's just a beautiful way to see the world. Less mechanical, more magical, but fully backed by hard science.
The best kind of magic, really.
Before we wrap up entirely, let's hit the did you roundup from the sources. These are just quick hits of curiosity to send you off with.
Hit me.
Did you try Grok 4.2? Apparently, Elon Musk is using it to seek the ultimate answers to the universe.
And naming his models accordingly. I haven't asked it the meaning of life yet, but I'm absolutely sure it has an opinion.
Did you hear the Gemini music model? It apparently speaks, or rather sings, in 8 different languages.
I imagine we're about to see a massive wave of AI-generated "We Are the World" style anthems flooding the internet.
And finally, did you celebrate the year of the fire horse?
I completely missed the party, but the source mentions robots doing kung fu.
Yeah, only in a fusion note would you get kung fu robots right after a deep dive into bioelectric theory.
It definitely keeps us on our toes.
So as we close this deep dive, we want to leave you with one final, slightly provocative thought straight from the source material. It's a concept called superpanpsychism.
This is the idea that if intelligence arose way before brains existed, which Levin argues it did, all the way back to single cells, then intelligence might genuinely exist everywhere.
If the universe started as a kind of cognitive glue,
then the source is everywhere. So as you go about your week, we want you to ask yourself, if the trees and your own blood cells and your gut bacteria are actually intelligent, What are they trying to tell you? What does that change about how you view the world?
Something to think about. Thanks for exploring the fusion note with us. We'll see you in the future.